Hello there, YouTube. As I've just explained to Twitch, um, our plan has been updated. We did sphere bounding volumes. It was a fairly easy implementation. We did the player controller, even though we could do further adjustment to the whole movement system. I think it ended up in an alright spot, at least for now. And we started doing a bit of sphere ABB collision checking, since the player controller is a sphere bounding volume. And the other meshes are ABBs. So we already did that. I had written down something that I wanted to do. Oil to quaternion conversions, lerp methods, and some OBBs, and some refactoring of the code in terms of restructuring things in a way where things made a bit more sense in terms of layout and how to implement different systems and interactions between the systems. But um, I decided that it's no fun. It's really no fun to do these things. Refactoring code and uh, so forth is kind of boring. I could do it off stream, um, but yeah, I'm not going to do it on stream today at least. I think I'll do it on stream, but yeah, it's it's not a very intellectually daunting task to do these things. It's just a bit time consuming, and this is strictly math based. So yeah, um, yeah, we might as well just skip it. So we will save that. Instead, I've tried to figure out what's not boring. Since we're doing a Doom/Quake clone, I'd say guns, shooting, and action is definitely not boring. What do we need to get into? Something that can shoot. We definitely need raycasting to see if we hit anything, and we need to check collisions for rays, and we need debugging for raycasting, meaning that we can actually see some rays. Yeah, I think I will be implementing a crude method to handle all of um, our rays. Let's see. Let me just change the overlay here. So yeah, we will be doing that. Yeah, our player controller is kind of done for now. We need to update it whenever we refactor our code. Our collision resolution here is also done. We will return to collision checking. And we will be doing an interface in our renderer. Where we will be able to read some rays. Right now we already have rays in our world. We have the origin, whoops, our jump here. which I think turned out quite all right. Let's see. Our origin here has the axis of the coordinate system shown, the positive part of the different axes. Yeah, so we can definitely do that. We already draw the bounding volumes as different lines. Yeah, so we can already draw different lines. What I think we want to create is something like, let's see, build debug information. So array is super simple. Uh, 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 Super simple. Since we will have two vertices and two indices for array. Um, we will be able to be able to uh, create a array debug kind of interval, which will be set to 0, but inside our renderer here will be used. And then we will add array debug times 2 and do the same thing for indices. And by that, we will build space in our buffer for a certain amount of race. Yeah. We could do some tracking internally. Um, yeah, we create the lights and we just create the extra vertices after the lights. Mm, I mean, it will be a bit messy. If we if we I mean, whenever we want to tell the renderer to add a visual, well, this basically just, well, maybe we don't. Well, this method is not, yeah, Yeah, I'm thinking of something else. I mean, will just be another parameter whenever we build the debug information. We can tell our application that we want to build debug information, and we want to create 5 arrays in memory, or rather, space for 5 memories. Memories, memory for 5 arrays. Let's see. Build buffers for debugging. Methods for bounding boxes. Let's see. Let's call that box instead. Whoops. Let's call this a box. This will also be a box. Let's see. Let's do spheres then. Maybe we want something like Ray start G float position end, and we will have a color, and we will not have any padding since it doesn't make sense. Update. This is going to be some, oh, this is not data structures, this is pipeline stuff. Create debug visuals. Oh well, it's the coordinates system we got there. Okay. We want something like like this, and G flow 3 in position, position, and let's do G low fat. Not entirely what we meant. and we specify a color here, and then void remove debug visual. This is going to be array, and this is going to be array, and we will remove it like that. So we'd like these three methods. Let's see, and where did we get them? All right, let's see. In our application here, we will fix names of these methods. Box. Box. There we go. Does everything compile? It does. Okay. Then inside our renderer, when we add a box, well, we'd expect if we call this afterwards. Yeah, this might get messy. Yeah, I definitely want a box offset of sorts. Yeah, we're running into trouble. We could do some debugging values here. Let's do unsigned int. Yeah. Ray offset. Debug ray offset. We'll just so the ray debug offset is equal to the amount of boxes plus the size of the lights. Meaning that the memory will start at this location. Let's see. And actually, I think maybe we want something like unsigned int current ray. Let's do debug. Unsigned int max debug max raise. Yeah, let's store this information because then we can just create a system where we can iterate over lines and replace the old ones. I mean, we will only have so many arrays. So if we add a let's see, vertex line. If we add, yeah, it will be easier just to array, or rather, just to create an array of points, and we do points 0 dot position is equal to position start. It is a position, which is great, and the points color is equal to the color. Great stuff, great stuff, great stuff. Okay, and we do the same for our second part, only it will have position end. Then we will we will set our current debug current ray to our well, we will of course yeah, we will just create a rendering item. Right now we can't remove anything. Maybe we want just something for the race specifically. We could do that. We could do that. But do we want to do that? Yeah, we will not be adding bounding volumes on the fly. They will be kind of statically created. Right now we can't remove different items. The vertices will never, I mean, I have named it box. I mean, the actual vertices won't change, but the debug item information will not change either. Yeah, it won't change either. It doesn't matter if I remove the old debug items. Eventually I'll just need to track at which offset inside the vector we could store that unsigned int mdebug vec offset raise vec offset. Yeah. Let's see. Yeah. So whenever we create a render item, we actually offset our raise here. So let's create a render item. And let's comment this out for now. So if we ask our system, you know what? Wait a minute, no, we do not need to ask our system anything right now. We will have a memory location that gets information about how far we need to offset either by vertex or ray, meaning that the index offset is this times 24 and the vertex offset is this times 8 plus debug current ray times 2 and the same here, and we will do like that. Let's see if this dot size let's see. Is equal to 5. we have a special case. Let's see, already created 5 race, or let's see, debug max race. Max race. Else we create a new we create another rendering item, and we do some mem copying. Let's try that for now. So we do vertex line, and we copy our points. And we do copy 2, our indices. Let's see, unsigned ints, indices, let's just do a initialization like this, 1 and 2. Let's see, times 8 times 24. So this might work. And we add a ray to this. Let's try it. There we go. Plus 2 times current debug ray. Do the same thing here. Let's try that. In our application, do we still have these random flags? Has been run. Yeah. And our layer controller, can't remember. I'm using the 6 and 7. If get async key state vk F8. If let's see, up here, yeah, we do create. Add debug visual array. Let's see, 0, f that's 0, wait a minute, and then we want it to end at maybe the x-axis somewhere. Let's say 10, and keep it floating. And then the color is going to be a bit of red, a bit of green, and 0 blue. There we go. Let's try that. It's probably not gonna work, but let's see. Yeah, it definitely doesn't work. I mean, that was not what I expected. Anyway, uh, so let's see. Did we get any console output? No, so we didn't. Let's see. If we step into this function and see what we calculate, we might get somewhere nice. All right, so our points here. Uh, 2 and our color. Let's see. Our position end. Wait a minute. Points. I mean, okay, that's correct. So the points are fine. What does the system have of values? Max rate, current, 8. So we have 8 items. 8 items. Let's see the So usually, oh no, wait a minute. It's fine. I think, so we offset into the memory. Let's see what happens visually. Is something missing? Whenever I can't see it. If yeah. Anyway, uh, so let's see. D-boys. Blah. Oh, I realized I need not to copy the vector offset. That will be way smaller, or rather, may not be the same. Let's try that instead. It's I'm not sure it's gonna change anything, but we're close. We're really, really close here. I mean, almost everything turned out right. I mean, almost. Almost. Did we not? Hmm. Ah, wait a minute. This has to be 0 and 1. There we go. We got ourselves a line. And if we disable this part, we will get an overflow message eventually. Right? Well, not. Let's just print that. Calc. Well, the first two several times 7. Maybe let's see, plus. So this is the total amount is equal to no. Let's see. No. Okay, let me see. So we will know our amount of thingies here. Oh, wait a minute. This, of course. Does this change anything? Yeah, it does. Rayback offsets. Oh yeah, we of course need to do it for the lights as well. I think. Oh, we don't do it like that. There we go. For the lights. All right, let's see. Yeah. Mm, let's see. Let's remove that. Let's remove that. Uh, let's see. We might overflow here. Uh, but we don't. But we don't. All right, so now we can just keep on adding rays and the old ones will get overridden, which is pretty great. Which is pretty great. Okay. We have our creation method. We create 5 possible thingies. Let's do. All right. We would actually like to be able to cast a ray from our character player controller, but we would like our player controller to be able to give us a vector, g vector get looking point, looking vector get forward, cam forward vector. And we will return the m camera dot get forward function. Our renderer doesn't need updating right now. Okay, so we want our player controller get cam forward vector, v vector value, and it should be normalized, meaning that it's a direction. We would like to start somewhere at the position float 3 start pos is going to be the player controller get position, and then we will do a scaling, float scaling equal to 50. Let's just do that at least. Math scalar the value and the scaling, and then we will have our endpoint gfloat endpos is going to be gfloat 3. It's going to be math load float, no, store float, and we will have a end position which we will initialize. And we will call store float end position, and then get the source, which is the value, and not valent value, and we will pass in a reference here. Then we want a start position, then we want a end position, and then we want a color. All right, let's see. We do like this, and then we press F1, and lo and behold, we fire a vector. We could disable this so that we will just create lines endlessly whenever we hold down the button. Yeah, there's a bug somewhere. As you can see there, it fills out. Yeah, but at least, let's see. That is great. We could get, instead of the player controller position, we could ask it for the um, inline vector get cam position. Yeah, we could also do that. We could comment this out and store the float in player controller. Get cam position. And now we will shoot a ray from our camera instead. For some reason it kind of bugs out a bit. Uh, yeah, whenever you're standing right inside the ray. So the start position could be translated a bit, I guess. G vector start is going to be math add vector add the value and then the camera position, and then we'll just add a tiny fraction of the vector. As you can see, everything works way better than there's something odd in terms of staring right down the vector. I mean, oh, wait a minute. We of course need to add the same thing here. Vector add value. There we go. There we go. Now we're shooting straight lines. Great stuff. Great stuff. So now we have raycasting. We just need to bind it to some sort of bounding volume where we can do intersections. Great stuff. So this will be it for this part. We now have raycasting, and it will just overwrite the old rays. We can do scaling. We could do timed events. Where we kind of pop the old lines after a short while. But yeah, it feels great to be able to cast some rays. Let's see, close the physics loop. And it's not that difficult in terms of code. You just have to calculate the start position, the end position, and then the color, and then just cast the ray. And it doesn't matter, even though you overflow, you will end up with several rays. You can always limit it so it only gets called once, but yeah. For now, this will do. We could do even longer scaling if we want to. Yeah. So that's it for the YouTube part. I'm gonna end the video there. Hopefully you found it enjoyable, helpful, or something else. Maybe you liked the part where I had a total misunderstanding on where to offset into memory. I don't have count on how many times I offset, mostly in the wrong place. Usually it works, but yeah. Anyway, thanks for dropping by. Feel free to comment, like, or subscribe, or even support the channel on the Buy Me a Coffee link. Alright, bye bye.